Welcome back to our next session, creating subsystem maps using infinity search. In this short session, we are going to see how we can pinpoint subsystems amongst very large number of programs. So the easiest way, if there are naming standards in a company, would be to use the naming standards to your advantage. For example, if we look for all the programs that begin with TT for timetable, because that's how the timetable system programs are defined, that would be very easy. The data name contains limits the search only on the names of the programs. So we haven't really searched inside the programs themselves, inside the code, only on the names of the programs. And we found all the names starting with TT. Again, in the insights of the search result statistics, which I highly recommend to use, it gives you an immediate breakdown of all the programs that were found, what data types they were, what documents, how many lines they have. So it gives you a very good indication of the magnitude of this project should you be working on all these programs. But this was a very easy way to pinpoint a subsystem because of the naming standard. If you don't have a naming standard, another way could be simply by finding a very unique element that the programs may be relating to. For example, if we search for a credit card, we'll probably find all the programs in our system that are dealing with the credit card. So again, here's the search result statistic, and here's the breakdown. Other ways could be by installing, as you load the programs, you can put meta tags inside the programs, allowing searches to find specific systems. So we do have clients that as they load programs, will put meta tags in each program specifying the owner, the system, and so forth. But in our session, we are going to do it using infinity search. So let's see how that works. With infinity search, the beginning point, the starting point of finding your subsystem can really be anything. Can be a field, a file, a routine, a programmer that was working on a program, anything. In our case, we are searching for a field called tax amount. And we're going to be looking at, by default, I want to find it in the MF types, mainframe types of COBOL, and I'm going to select all the other types that work together with the COBOL, like copybooks, and we have JCLs that call the COBOLs, and we have PARMs and procs, all those work together. So we initially perform the first search, and what do we get? We find some COBOLs and copybooks that are related to tax amount. But that's just the beginning point. We got to branch out to anything that may be related to these programs. And for that, we use infinity search. Infinity search allows you to take the results from one search and then select one or a few or all items and throw them back into the search criteria for a new search. So here are all the names of programs and copybooks that previously we found. And now, because we have selected the COBOL, copy, JCL, PARM, and PROC, we are searching for any of these names in all those data types. And we start to expand the scope. Now we grew from 60 programs to 100 programs. We added 4 PARMs and 55 procs. And they're all here on the right. We are going to do another infinity search in selecting everything and push it back to the criteria once more. And do another search. And now we've expanded to JCL as well. So we've grown to another 11 programs. We've grown all these JCLs and so forth. So using the infinity search, you slowly expand the scope. Eventually, the numbers will stop growing. If we did one more and selected everything and searched again, you see we grew even more to 130 programs from 111 and so forth. What this allows you to do is to begin with any criteria you start with, in our case, a field of tax amount, and within a minute of performing just a few searches, to find all the related and touching elements. And now if we want to draw a map of how all this works together, we can perform yet another action. And if you haven't guessed, these actions all refer to something we're doing to all the programs and the search results here. So now we want to do a search XREF, meaning give me an XREF report for every single program and map out how they work together. So there's 435 items here, quite a bit, and we're going to tell the system to generate for us a map of how all these work together. This takes a few seconds. Nothing in SmartDS is pre-canned. Everything is done on the fly, real time. And here are the maps we get. And so you can see that the JCL goes to the proc goes to the COBOL goes to the copybook. When you look at these lines, if you put the mouse over a line, you can see exactly the line making the link. So JCL has an exec, that program name. And that COBOL has that proc execs PGM, that COBOL. And that COBOL has a copy statement for that copybook. And you can save into multiple formats for export. Since at times these maps can be quite big, you can search the diagram. In our case, we're searching for OPIE, and as you start to type, it drops down the elements. For example, the JCL, and when you search, it'll draw a little arrow right next to the element you're looking for. If you want to simplify the diagram, meaning you don't want the COBOLs, only the JCLs and procs, then you can remove the COBOL, and now you're going to get all the JCLs to procs and parms relationships. It's important to note that after we do the search, and you have all these informations of the insights here, all these can also be exported as artifacts for later usage. The actual search result can be exported right here, and your search result statistics can also be exported right there. One other thing you can do with this subsystem now is do one more infinity search to get all the elements back to the search criteria. So you have them here. And now I'm going to do a little trick. I'm going to request a complexity analysis instead, and I'm going to put data name in front of this. So basically it's only searching for the programs, and what I'm getting is I want to know the complexity level of all the programs involved in this subsystem. So now, if you go to the end, I've basically told the system, instead of search, do a complexity analysis for all those programs. And here are all our COBOLs, all the elements that were part of our system. We can now get complexity information for them. So starting from one little field, we grew to a subsystem, we mapped it out graphically, and we have the complexity analysis of it as well. That was a short session about mapping subsystems using Infinity Search. And now I'll open up to questions.